In this lesson, we will be simplifying radicals. And if you notice, uh, this equation is already written in factored form. So you notice that x plus 2 and x plus 2 become 1, and you're left with x plus 5 over x minus 5. So that would be the most simplest form. Now you have to remember, even though it's simplified to x plus 5 over x minus 5, when x is not equal 5 and x equal -2, that is a restriction. For example 2, it says, what are the following products in simplest form? State, are there any restrictions? Now you notice that we have y here and we have z. So the only values that we can't have y in there, or any z value that we can't have in there, is 0. Those are our restrictions. I'm going to go ahead and write it in factor form. We have 3 times x over 5 times 7 times y times 7 times 7 times y. 7 times 7 is 49. 5 times 7 is 35 times y. And then we have 3 times 4 times z. We got to check if anything becomes 1. And if you notice, we have 7 divided by 7 is 1. Also y. Y divided by y is 1. We also have 3 divided by 3 is 1. And so that's what we're left with. So what we have is 3 divided by 3 is 1. 7 divided by 7 is 1. Y divided by y is 1. So you have 7x over 20z. Okay, in this product, or in this rational, we have x minus 2 over 5x times 10x over 3x minus 12. What I'm going to do is I'm going to go ahead and simplify. I have x minus 2, and then we have 5 times x times, and now 10, I'm going to write it in factored form. 2 times 5 times x divided by, now a common factor is 3, and you're left with x squared minus 4. And now you notice that we have a 5 here and a 5 here in the numerator and the denominator. We also have x, and we also have x in the numerator and the denominator. Those are going to become 1. Okay. So now, what do I have left? I have 2 times x minus 2 divided by 3. Now, x squared minus 4 can be simplified, can be factored. So you have x plus 2 times x minus 2, and you notice that this right here are the same. X minus 2 and x minus 2 are the same. So that becomes 1. So what are we left with? 2 over 3x plus 2. Now, the restrictions, x can't be 0, because of this right here. And x cannot be 2, or x cannot be -2. Rewrite each quotient as a product. Use this to find the quotient of the rational expression. Okay, so we know that y can't be 0, z can't be 0. That's because of division by 0. So we have 3 times x, and I'm writing in factored form, 2 times 2 times y, divided by 2 times 3 times x, divided by 5 times z. Remember that when you're dividing fractions, you're going to have to change it to multiplication. In the second fraction, you're going to have to find the reciprocal. So you have 3 times x over 2 times 2 times y times 5 times x divided by 2 times 3 times x. And you notice we have the 3 here and the 3 here. We have the x here and the x here. Now this right here was z, not x, it's z. Do we have anything else? I don't think we have anything else. So we have to add another restriction, x cannot equal 0. So what you're left with is, this becomes 1. So you're left with 5z over 2 times 2 is 4, 4 times 2 is 8, and it's 8y. So that simplifies to 5z over 8y. So we're going to simplify this rational. The first is identifying the restrictions. We have x can't be 1. We also know that x can't be -1, because if you put -1 into here, it's going to make it undefined. So we're going to start by using this fraction first. Find the greatest common factor. We have 7. You're left with x plus 2 divided by x minus 1 times, they went ahead and did the reciprocal. So you have the greatest common factor is 5, so you have x squared minus 1. You know the greatest common factor is 7, so you have x squared minus 4. So now you notice that the 7s, you have a 7 here, and you have a 7 here, so that becomes 1. Now we're going to factor x squared minus 1, so you have x plus 2 over x minus 1 times x plus 1, x minus 1, and then you have x plus 2 times x minus 2, because these are the factors of x squared minus 1 is x plus 1, x minus 1. And the factors of x squared minus 4 are x plus 2 and x minus 1. This becomes 1. This becomes 1. So I'm going to go ahead and simplify. That becomes 1. This becomes 1. So what we're left with is x plus 1 over x minus 2. And we did have a 5, so I forgot the 5 here, so it's 5. So restrictions, x can't be 1, x can't be -1, x can't be 2, and x cannot be -2. So those are the restrictions. And this is when it's simplified right here. We're going to go to example number 4. It says, what is a quotient of 2 minus x over x squared plus 2x plus 1 divided by x squared plus 3x minus 10 over x squared minus 1. So what I'm going to do is I'm going to go ahead and I'm going to factor already. We have 2 minus x. If you factor x squared plus 2x plus 1, it's going to be x plus 1 times x plus 1 times, you're going to have to get the reciprocal of this fraction, x squared minus 1 over. So you got to find the factors of -10 that add up to be 3. So we have x minus 2 times x plus 5, right? Now you notice that we're able to factor x squared minus 1. So it's 2 minus x over x plus 1 times x plus 1 times x plus 1 times x minus 1 divided by x minus 2 over x plus 5. Restrictions, x can't be -1, x can't be 2, and x can't be -5. These are our restrictions. Okay, so now we have to look at which ones become 1. So x plus 1 and x plus 1 becomes 1. Now, I want you to notice something. If I factor a -1 from this expression, that negative x becomes positive, and that positive 2 becomes negative. And you notice this becomes 1, right? So what is this factor to? X minus 1 over x plus 1 times x plus 5.